Good afternoon, everyone. It is always a pleasure to talk about science, technology, and general mathematics. Here we are with our guest, Bill Kuhl, who is going to talk about the many things that has to do with electronics and electricity. Welcome, Bill. Hi, how are you?
I'm good.
So now the floor is all yours. Go ahead.
Okay, so I've got some of my toys in front of me. I mean my visual aids. When I speak to a group of it's kids, or lately it was more like nursing home presentations, but everybody seems interested when you have lots of things to demonstrate. It just seems to make it so much more interesting than if you're just speaking. Now this here is something I had purchased. It's a very simple electric motor, but I think it really demonstrates kind of simply how an electric motor works. An electric motor, it works with magnetism. Now this has two permanent magnets, and magnets, they have a north and a south pole, and magnets opposite polarity attracts, or similar poles will repel. And this is the basis of how the motor works. It uses the permanent magnets on the outside, and it has electromagnet on the inside, which is known as the armature, which has coiled wire, and when electricity passes through coiled wire, it creates a magnet. And the brushes here that make and break contact to turn the electricity on and off, and it changes polarity as it goes around. So I'm going to flip the switch now, and the motor will start running. Now, being that this only has two poles, you have to get it started. It will not start on its own unless it's at the proper place. But that's a simple electric motor. Now on my website I have a real simple electric motor that I've had students build, and it's basically just a coil of wire, and here's the permanent magnet, and the enamel coating is sanded off so that it makes contact for part of the spin around, and then it insulates for the other spin. There, I think you can see it better. So this is just the single coil of wire with the make and break connection. The thing about building this project, it's good for kids, but it does take some accuracy. And I had a little trouble with some of the kids. They didn't coil the wire neat enough. It has to come real close to the magnet, and then they have to sand off that connection real good.
These are some awesome stuff.
Now, in modern vehicles and model airplanes and model cars and all that, now you hear about brushless motors. A brushless motor does the switching electronically. There's a little circuit board in there, and somehow it can tell the position of the magnets. And this is what they call an outrunner motor, because the magnets are on the outside. You can see all the little magnets on the outside. And then the coils are on the inside, and there are no brushes at all. So I'll put this back together and plug in the battery. And this is a lithium battery, which has a lot of energy for the size and weight of it. And that's what we're using. And you hear those two little beeps, and that means it goes through its startup procedure. And now if I turn this diode, it'll increase the electricity into it.
That's really cool.
So that's the brushless motor. Another thing with electricity, besides using batteries, is the capacitor. And they're getting capacitors with greater capacity now, and the hope is with electric cars and that sort of thing, they could use a capacitor in place of a battery. A capacitor will charge up very fast, but it also releases the energy fairly fast. So it's not ideal, but it could be used just to capture energy as the car was braking and then get it going again. Now if I flip this switch this way, it's going to charge this capacitor. And then when I flip the switch the other way, the electricity will come from the capacitor and not the battery. In fact, I could take a battery out of here. And you see, there it runs. And another thing that I've been real interested in lately is electronics and waves and how radio waves go through the atmosphere. And I had bought this simple shortwave radio at a hobby shop. You just attach wires between springs to connect the circuitry. But this little radio, it will actually pick up stations in other countries. And I've got an amplifier here. I'm going to turn on and we'll see if we can pick up anything. Now the reason that this can pick up stations is so far away because this particular band of frequencies, the radio waves bounce off the ionosphere, and you can receive things much farther than normally you can. Normally I think on a radio station maybe 30, 40 miles, as far as you could receive, but this is going actually hundreds and thousands of miles, and that's because these radio waves bounce off of the ionosphere. Now this, it kind of varies. It seems like you can get certain frequencies in the morning and other frequencies you can get at night, but you can't actually, count on it to work all the time. So that's another thing I've been exploring was radio waves.
So, thank you very much, Bill, for such a wonderful demo.
Uh-huh.
So we will be more than happy to have you in the future as our guest for some other demo. And
Okay.
also, I would like to have you so that we can talk about what do you expect in STEM for this year, 2020. I thank you so much for your time today. Until next time, enjoy the weekend.
All
We'll talk
right.
soon. Thank you so
Thank
much.
you, Milton.
Bye bye.